Now that we have an idea of what a polynomial function's graph looks like, we're going to read through the steps that you would take to graph a polynomial function of a higher degree. Okay, now once we read through these steps, we're not going to immediately start graphing, because you're going to see as we read through this, there are some things we've never talked about. So we're going to go through these steps, and then after that, we will start going through each term that's mentioned that we're unfamiliar with. That way, we completely understand how to graph a polynomial function before we even start. Okay? All right, so here we go. Under how do you graph a polynomial function of higher degree? Okay, I will be highlighting the words that are new to us. All right, step 1. Identify the degree and leading coefficient of the polynomial function, and use these to describe its end behavior. Okay, so end behavior is a new word. Okay, so basically what end behavior is, and that's what we'll do on the next page, but end behavior is how your function behaves as the x values get bigger and bigger and bigger, and as the x values get more and more and more negative. Okay, so what's happening at the endpoints of the function, essentially. Okay, step 2, determine the zeros of the polynomial function. Okay, new word. Okay, these zeros are the x-intercepts of the graph. Okay, so this is a new term, maybe not a new idea. When you hear this fancy word zeros, find the zeros of the polynomial function, it's just asking you to find the x-intercepts of the polynomial. Okay, to find the where the graph is going to cross the x-axis. Okay. All right, so once we find the x-intercepts or zeros, we are going to need to determine the multiplicity of each zero, and then use that information to determine whether the graph will cross or touch the x-axis at each zero. Okay, so there's a lot going on there, but basically what you need to take away from this is that you're going to have to find the zeros of the polynomial, meaning find its x-intercepts, and then what's going to happen for each x-intercept, there is going to be a number called a multiplicity associated with each x-intercept. Okay, multiplicity is just a number, and I will show you how you determine the multiplicity, and based on what the multiplicity is, it's going to determine whether your graph is going to cross or touch. So let me just show you a quick sketch. So say we have our axes here, okay, and let's say here's where our x-intercept is. Okay, so here's our x-intercept. This is what it looks like if your graph crosses. Okay, if your graph crosses, see at the x-intercept, it's going from, well, I'm having trouble drawing it. Okay, there we go. Maybe not. Hold on. It's not cooperating. Come on, thing. All right, let's just do this. So say this is the x-intercept instead. Okay, so notice what's going on here at the x-intercept. The graph is crossing the x-axis, so it's going from below to above. Okay, so this is a cross. Okay, and then if instead you had a touch, okay, you would have at this x-intercept, say we touched, your graph would come down, hit the x-intercept, and just touch it and go back up. It would not cross over to below. Okay, so basically the multiplicity determines whether the graph will cross or touch at each x-intercept. Okay. All right, going on to step 3. Okay, remember, we love additional points on graphs. The more points we plot, the better the graph looks. So in step 3, one great point to plot is the y-intercept. In number 4, we're going to need to identify the maximum number of turning points. Okay, so that's a new word. In a nutshell, what a turning point is, these are points where the graph changes from increasing to decreasing, or from decreasing to increasing. okay? So that's what turning points are. When you draw a polynomial function, you have to make sure that your polynomial has the correct number of turning points, okay? And then last, you kind of put all this information together. In step 5, you're going to plot the x-intercepts and the y-intercept. You're going to sketch a smooth and continuous curve that passes through these points and exhibits the required behavior at each zero and the required in behavior and abides by the maximum number of turning points, okay? So you may have to read through this again because we were kind of distracted by the fact that there are so many new terms that we're going to have to go and learn before we actually start graphing polynomials. So what we're going to do now, we're going to start with in behavior. We're going to go and discuss that. Then we'll spend some time on zeros and multiplicity and cross or touch. And then we'll quickly go through turning points because there's not much there. And then we will start sketching rough drafts or rough sketches of polynomial functions of higher degrees. Okay, when we get there, we will revisit this checklist. Okay, so let's take a look now at in behavior.